Your brain is not the same organ it was 5 minutes ago. Every time you learn something, it physically rewires itself. Not metaphorically, physically. New connections, new shape. For a century, scientists believed the adult brain was fixed at birth, fixed by adolescence, done growing by 25. This idea shaped how we raised kids, taught school, treated injury. If you were bad at math, that was just your wiring. If a stroke damaged a brain region, that function was gone forever. Doctors told patients, whatever you have now is what you keep. Teachers told slow learners, some brains just aren't built for this. This belief had a name, neurological determinism. It felt scientific, felt final. It was also wrong. In 1965, a scientist named Marion Diamond ran a quiet experiment. She raised rats in enriched cages, toys, tunnels, other rats. Compared to isolated rats, their brains were physically different. Thicker cortex, more connections, more support cells. The adult brain wasn't fixed. It was listening the whole time. So what actually is neuroplasticity? It's your brain's ability to physically reorganize itself through experience, not just chemically, structurally. New wiring, built from scratch. To understand it, you need to understand one basic unit, the neuron. A neuron is a brain cell that sends and receives signals. It has branches called dendrites and a long fiber called an axon. Neurons don't touch. They communicate across tiny gaps called synapses. Every thought, memory, and skill you have lives in this network. In 1949, psychologist Donald Hebb proposed a simple rule. Neurons that fire together wire together. When two neurons activate at the same time, their connection strengthens. Repeat that firing pattern, and the synapse gets physically stronger. This strengthening has a name, long-term potentiation, or LTP. LTP is the cellular basis of learning itself. Here's what that looks like under a microscope. A dendrite starts smooth. After repeated activation, it sprouts a spine. That spine is a new physical connection point, a new synapse. Learn a new skill, and your brain grows new spines within hours. Stop practicing, and unused spines shrink back. Use it or lose it. This is why cramming fades but practiced skills stick. But strengthening synapses isn't the whole story. There's a second mechanism, myelin. Myelin is a fatty sheath wrapped around your neuron's axons. Think of it as insulation on an electrical wire. More myelin means the signal travels faster, up to 100 times faster. Cells called oligodendrocytes build this sheath, one layer at a time. Every time you practice a skill, you thicken the myelin around that circuit. That's why a beginner's movement looks slow and effortful, and an expert's movement looks instant. The signal is just faster. This is neuroplasticity's second law. Repetition doesn't just strengthen, it insulates. Now here's the fertilizer behind all of this. A protein called BDNF, brain-derived neurotrophic factor, BDNF for short. BDNF supports the growth and survival of new neural connections. Exercise, novelty, and sleep all increase BDNF production. Boredom and chronic stress suppress it. This is one reason movement and learning are so tightly linked. Let's look at real evidence this happens in real adult brains. In 2000, neuroscientist Eleanor Maguire studied London taxi drivers. To get licensed, they had to memorize 25,000 streets. The knowledge. She scanned their brains before and after years of training. Their posterior hippocampus, the brain's spatial memory hub, had grown. The longer they'd been driving, the larger that region was. This wasn't childhood development. These were fully grown adults. Their brains had physically restructured around a skill they practiced daily. The same pattern shows up in musicians. String players who train for years show an enlarged motor cortex region, specifically the area controlling their left-hand fingers, the ones doing the work. Practice didn't just make them better, it rebuilt the tissue. Now here's where it gets even more important: recovery from injury. After a stroke, a damaged brain region can lose a function completely. For decades, doctors assumed that loss was permanent. Then came a therapy called constraint-induced movement therapy. Patients had their unaffected arm restrained for hours, every day. Forced to use the weak arm, the brain built new pathways around the damage. Healthy tissue took over jobs the damaged tissue used to do. This is neuroplasticity working as rehabilitation, not just learning. It proves something critical. The brain can route around damage. Not always fully, not always fast, but far more than once believed. There's one more piece: sleep. During deep sleep, your brain doesn't just rest. It edits itself. It strengthens the connections you used that day, and it prunes away the ones you didn't, clearing metabolic clutter. So what do you actually do with this? First, understand that struggle is the mechanism, not the enemy. That awkward, effortful feeling when learning something new, that's spine growth. If it feels easy, you're not building new connections, you're coasting. Second, space your practice instead of massing it. 1 hour today beats 4 hours once a week. Spaced repetition gives synapses time to consolidate between sessions. Cramming builds a connection that decays before it insulates. Third, sleep is not optional. It's part of the learning process. Skip sleep after practice, and you skip the consolidation step. The myelin doesn't get laid down. The memory doesn't get filed. Fourth, add novelty, not just repetition. New, unfamiliar challenges trigger more BDNF than routine ones. Learn a language, an instrument, a new route, anything unfamiliar. Fifth, pick one skill and go deep before adding another. Divided practice divides the myelin. Focus concentrates it. This is why elite performers specialize before they diversify. Sixth, move your body. Exercise raises BDNF and primes the brain to encode what you practice next. Even 20 minutes of walking before a study session helps. Here's a simple weekly structure to apply all of this. Pick one skill. Practice it in short, focused sessions. Space those sessions across days, not hours. Sleep right after practicing it, whenever you can. Add movement before your hardest sessions. And expect the discomfort. It means the circuit is under construction. None of this requires talent. It requires repetition done correctly. Your brain was built to do this. It's doing it right now. So back to where we started. Your brain right now is not fixed. It's an active, adapting structure, updating itself with every experience. The scientists who believed it was fixed weren't lying. They were early. The evidence has now caught up. Taxi drivers, musicians, stroke survivors. All proof of the same underlying rule. Use rewires you. This is also the biological foundation of something called a growth mindset. Believing you can improve isn't just optimism. It matches your biology. Your brain is quite literally built to become someone new. The only question is which circuits you're going to build on purpose. Right now, most of your practice happens by accident. Whatever you repeat, worry, doubt, distraction, gets wired in too. The same mechanism that builds a skill also builds a habit of mind. That's not a metaphor. It's the same synapse, the same spine, the same myelin. So the real question isn't, can my brain change? It's, what am I currently training it to become without noticing? If neuroplasticity explains how your brain changes, the next video in this series explains how to point that change on purpose. That's where growth mindset actually comes from, not motivation but mechanism. Go watch that one next, right after this. Your brain doesn't care if the wiring is useful or not. It just wires what you repeat. So repeat on purpose. That's neuroplasticity, not a metaphor, a physical, provable, daily rebuild.